Hello and welcome everyone. So in today's video, I wanted to start a mini series on retrieval augmented generation or RAG. But there are so many complex topics embedded in RAG that I want to break it down into smaller portions of videos that you can digest easily. And whenever we talk about RAG, many of us have asked me this question that, hey, I just take a piece of code from somewhere online and I run it and it works. But can you explain in detail what's happening behind the scenes? Like how are things working, which is what we'll try to focus and address in this video. So I want to show you a full-fledged working example. So you will have a full example over here that works, but at the same time, I'll walk you through what is happening when we are doing retrieval augmented generation. But in this video, I won't cover end-to-end everything, but I will cover the part where you can take a document, you can index it, and then you can retrieve from it. And then in the part 2 of this video, we'll go in and we will generate from the retrieved text. And we'll see all that come together in the next part of the video. So in this very first part, let's talk about what is the concept of RAG. So in retrieval augmentation, we take a document or a bunch of documents, and then we do put them somewhere such that they are easily accessible when you are trying to search through them, right? So for example, in this case, we'll take one of the World War II documents that I found over here. It was just online, freely available in the history kind of section somewhere. And this is a pretty decent sized document. It has images, text, and all that. And it is like 100-page something, I think. Okay, all right, about 50 pages of document over here, which is a decent sized document, right? So what we're going to do is we're going to take this document and we will put it into something called an embedding database. And we'll talk about what an embedding database means. And before we put this document in a collection inside an embedding database, we will actually break it down into smaller pieces, and then we will put it into an embedding database. And this is what we will talk about in today's video. So before we dive into detailed concepts, I want to show you what a run end-to-end will look like of such a process, right? And then once we have run through this process, I'll go on and I'll explain what is happening in the background. So let me show you. Whenever you have a RAG pipeline running, you start with some kind of search string that you have. So for example, I want to search for anything that says hot weapon, right? Within that World War II document, right? I want to search for this similarity search for this particular word, or you can even write more thing, hot weapon used by Germans, right? And I'm just making something up over here, but still, let's see if this is the search text, then what are the relevant portions of the text that are returned back to us? So what happens is then we provide a document to the whole process. And this document is then broken down into, it is read into text, and then it is broken down into smaller manageable chunks. And then once it is broken down into smaller chunks, then we create something called document objects out of it. So these chunks are just text chunks, and then we're going to create some document objects out of it. And then all these document objects are created, and then we index these documents into something called embedding database. And I'll explain all these things in detail. I'm just gonna run through this script once so you can see what's happening. And then once we index it, indexing is the part that takes a little bit of time, because each and every document, first its embedding is being created right now, and then it is being indexed. So you see that the whole big document was broken down into 108 smaller bite-sized pieces over here. Like you can see 108 of them. And for each 108 piece, and something called an embedding was created. and then that embedding was being used, and then it was put into our embedding database, which is Chroma database. And then we will now convert the query that we had into embedding 2, and I'll talk about it, what it means in a second, but we'll convert that query into embedding. And then this is the query hot weapon used by Germans that we provided at the start. And now a similarity search will be done, where we will convert, we will take this embedding for this particular text, and we will search it in our Chroma database. So now these were the 10 relevant documents that were returned back by the Chroma database. So hot weapons used by Germans was the text. And then there are equipments, organization in a non-technical way, firepower and all that, right? So something it found as the very first document. And if you'll see, there is a score over here. So score is the lower the score, the higher the search value is over here. So you will see the very first document has the lowest score, and the second document has slightly higher score, and then that's how it keeps on going down. So think of score as how far away your search term is with this chunk of document that was found in the Chroma database, right? So there are multiple documents in the Chroma database because you have split your original text into smaller chunks, and the score is the distance between your search term and the document that was found over here. So now let me go and explain what is happening when we ran this script. So in a RAG scenario, we take our original PDF document. So let me just open this Git repo that I have created for you. And in this Git repo, let me just go over here so you can see this. All right, so large this. Okay, perfect. So what we're going to talk about over here is our original document. So this is our original document. This is the World War II PDF document that I found online. And we're going to take this document and we will convert this PDF into text first. So all of our embedding databases that we have over here, we're not going to store PDFs directly, but we are going to store portions of text in our Chroma database, in our embedding database. So we're going to take this whole PDF document originally that we have on the left, and we'll convert it into a text. And then there are certain libraries that help us do it. In our case, we are using a library called, and let's take it to the requirements.txt, PyPDF2. This is the library that we are going to use to convert our PDF into text. And then it will be a huge, long, big text that we get from this, right? So it was a 48-page PDF, and it will give us maybe like about 45, 48 pages of text too. A huge, long text. Now, we cannot just take one single text and insert it into the Chroma database. I mean, can we do that? Yes, but then it won't be useful for us. What we want to do is we want to break down this text into smaller pieces, so such that each piece will have some kind of relevance when we are searching for it, right? So for example, if there are 10 sentences in one document, and we want each sentence to be its own chunk, and we want only one sentence to be returned when we are searching for an attribute. So we take this whole big huge document and we return we break it down into smaller chunks. So let's take an analogy over here, and let's try to see what Google does, right? So if we go on google.com, and let's say if you want to search for any special product, right? So let's take an example of SAP commerce, right? So now when you search for this thing, you saw there are smaller chunks of things that are being returned over here, right? You're not getting the whole SAP commerce, whatever this website is, in one full go, right? So you're only getting smaller chunks of information back that are relevant to you. And then you can choose to go deeper into it and you can look deeper into it. But what the very first result that you get back is just a small subsection of the whole document that you have. So think of this website as the big whole document and this search result as a smaller chunk of that search result, right? So making this analogy over here, let's come back. So we have the whole full document as the main website over here. And we converted that into smaller text. Now this is our full website is what we are saying. And these smaller chunks are what we want to see as the search results when they are returned back to us. So these individual chunks are each one of these search results when we are getting back from here, right? So this is the whole thought that we want to break down our huge piece of text into smaller chunks of text so that when we search, we get each one of these smaller chunks of text back. We don't want the whole document back. Why? Why wouldn't we want the whole document back? Because in any RAG implementation, the idea is that we will take these smaller chunks and then we will pass it back to our implementation of LLM, right? So in our case, it is Ollama. So we'll take one of these chunks or few of these chunks and we will send it as a context to our large language model. And the context window of these large language models isn't infinite. We aren't there yet. We only have a finite context length for these large language models. So what we want to do is we want to find the most relevant sections within this whole text, right? We want to find the most relevant sections within this text, and then only those relevant sections is what we want to pass on to our large language model in future. So what we do in preparation for doing all this, what we do is we take our original document, right? This and this is almost the same thing because this is just the text representation of the PDF. So we take our original document and we break it down into smaller chunks. And then we only pass the most relevant smaller chunks of the document into our Ollama server or into our OpenAI server where the large language model is hosted, such that the hosted large language model's context window is being respected, right? We only pass the amount of data that is required by our large language model and not the whole document to it. I mean, if we had infinite context length, then yes, it would just make sense to pass the whole document in there, right? We do not have to find the subsections of this document and pass it along. But we are not there yet, so we have to work with what we can, and that's where this RAG implementation comes into picture, that we take a whole document, break it down into smaller chunks. And now, in order for us to break down a document into smaller chunks, right, there are multiple strategies that are available, and you can go online and you can look different strategies that are available for breaking down a big piece of text into smaller pieces of text, right? So like, for example, you can break it down at a new line, or you can break it down at a certain character length, or you can break it down at end of every paragraph, right? So there are multiple ways in which you can do it. And in this particular approach today, I have just broken it down in terms of a fixed length. So every 1000 character, I think that is what I've chosen. I can double check and see over here. I think it is 1024. Every 1000 characters, the chunk size is 1000 characters. And when I'll run this program again, I'll show you where it is. But there is 1024 characters of each chunk that I have. So each one of these are 1000 characters long, and there is an overlap of 50 over here, right? Chunk overlap of 50. What does that mean? So an overlap means that if you are having a piece of text and you have broken it down into smaller texts over here, so the end of this, right? So last 50 characters of the previous text will repeat as the first 50 characters of this text, right? So this really helps in performing similarity searches. because now when you'll be searching for a document over here, and if you want to find the next document in terms of similarity search while using embedding, then having that overlap really helps the model, the embedding database to find out what is the most similar document which is next to this document. So it really helps out in doing the embedding related searches and doing the similarity searches. And that is why you will see that we have overlapping content in each document, and that is perfectly fine to do that. Now the overlap, whenever we pass it to the large language model, right? Let's say if you pass these two documents and the second document already has part of the overlapped first document. These large language models are smart. They are smart enough to detect that, hey, you used RAG and you had an overlapping document over here. So they will put these two together and they will, kind of weave them together and form a common text. And you do not have to do any such thing. The large language model will do it for you. So now you had your original PDF, you broke it down into, you converted it into text, and then you broke it down into smaller chunks, smaller texts, right? Now, once you have broken down into smaller chunks of texts, then you have to convert it into something called a document object, right? So this document object is, it's just a fancy word. It is the same text that you have plus some metadata related to the text. For example, just the file name, right? So worldwar2.pdf is what we used over here, and we can just use the same small piece of text and the file name, and we will put it over here. And this is how we'll create one single document for each one of these, right? So in this representation, I'm just showing one, but there is one document that is created for each, right? So in case we broke down this particular text into four chunks, then there will be four such documents that will be created over here, right? So we'll have four such documents created. But let's take one of these documents, and what will we do with this document now? So now for each document, we will create something called embedding. And there comes the very first, most complex term and the easiest to understand term in RAG. What is an embedding? So embedding is, so in order for me to explain embedding, let me talk to you guys about how you see the world. When you take a look at this world, you are looking at three dimensions: X, Y, and Z axis, right? And whenever I ask you that, hey, how far away, let's say your computer screen is from you, and you can actually gauge that in X, Y, and Z axis, it is maybe like an arm's length away. And then you will say it is maybe 2 feet away from you. And then if I ask you how far away is your TV, and then you can gauge it that, okay, yep, the TV is about 6 feet away from me. So the distance, the Cartesian distance, right, between two points in space is what you are responding back with. So the distance between your eyes and an actual object is something that you can gauge, right? So keep this thought in mind. The Cartesian distance is the distance between x, y, and z axis, x, y, and z coordinates of two different points in space, right? So you have one point as your eye, second point as your computer screen, and that is what the distance is. So now, when you are converting any particular document into embedding, all you are doing is you are converting this document into its Cartesian representation. However, the tricky part is you are converting it into numbers, but not in three-dimensional space, but in a multi-dimensional space. So you are taking this document and you are just putting it into a multi-dimensional space that you cannot even imagine how it looks like, right? But it is just generating 1,000-dimension space for you. And you are just throwing it out there in 1,000-dimension space. Now, if this one document is in 1,000-dimension space in one place, and the second document is in 1,000-dimension space in the second place, and then if I ask you what's the distance between these two documents, right? This is what the similarity search means, that calculating the distance between the two documents while they have been thrown in a multi-dimensional space. This is what a similarity search means, and we'll see where this comes into picture in a second. But in a very simple terms, taking a document and converting it into an embedding is what the embedding function does, right? So in an embedding function, you take an actual document, which is representation of a text, and then you just throw it out and put it in a multi-dimensional space. And in very simple terms, an embedding function converts a document into its numerical representation. So if you ever convert any document into its embedding, it just means you have a long length, 1,000 character, no, well, not 1,000 um, parts of its representation in X, Y, Z, and then all the way up to 1,000 axes, and that is what its multi-dimensional representation is. So you create an embedding of it. How do you create it? So all this problem has been solved for us already, so we do not have to write any kind of mathematical function to create an embedding. So there is something called an embedding model, right? So if you go to olama.com, and then you go to your libraries or models, then there are different kinds of models that you have. There is a regular large language model that you see, right? So Llama 3.1, and then there are certain models that are embedding models, like Nomic Embed Text, right? This is one of the embedding models. Like if I click on it, you can see that it generates embeddings for you. So there is an /API/embeddings endpoint for Olama, and that generates the embedding for you. So all you have to do is to pass your particular piece of text to this endpoint, and you have to specify the model name which you want to use, and you will in return get the response back as your embedding. So let's do that. Let's take this particular example and let's send it over here, and let's see what do we get as a response back. So you see the response is just a ton of numerical representations, right? And what are these representations? These are actually XYZ axis, and you have just thrown it out there, right? So these are, I believe, Nomic Embed Text does a 768 dimension representation. So these are 768 numbers right here. And there is another model, I believe. This is the one that I'm using over here, mxbai-embed-large, and this does 1,000, if I'm not wrong. So that this will return 1,000 over here, like 1,000 numbers over here. So I'm just gonna paste it. It's gonna hit send, and these embedding calculations are very fast. So you will see that this is 1,000 numbers that it spit out over here. So this is huge. Now this is all an embedding is. So for this particular text, this is an embedding. That's it. And what an embedding database does, it just takes this and it stores it in the database along with this text. And we'll see how when we go next to our this step over here, the next step. So you take this particular document, you run it through an embedding function, right? And how do you run through embedding function? Just by, passing it to this endpoint. You pass it to this endpoint, your text, and then you run it through embedding function, and you get embedding for that document, right? What is the meaning of embedding for the document? It is just all this bunch of numbers. That's it. So once you get these bunch of numbers, you take this original document, you take the embedding for the document, you put some more metadata together along with it, and you collect all these three things together and you insert it into an embedding database, right? So you put it into the Chroma database. Now this whole thing is in the Chroma database now. And you do it for every single chunk of document that you have. So you take the first one, take it over here, create an embedding, run it through the embedding function, create an embedding, put the document together, insert it into the Chroma database. Take the second one, the same process, put it into the Chroma database. Third one, fourth one, they all go through the same process and you put them into the Chroma database. So in Chroma database now, you have a ton of such documents, right? So they are put into the Chroma database and you have these documents just being put over there as multiple documents in your Chroma database. Let me just create this representation over here to do this. Let me exit out of there. All right, so now that we are out of Teams, so this is our Chroma database representation now. So I've just represented it in 2D, right? It's just a two-dimensional representation. However, in, like I said, this is in reality a multi-dimensional representation. So just keep in mind all of our objects now are thrown into a multi-dimensional space, into the Chroma database, right? So in this case, well, if we want to be consistent, in this case, we had 4 documents, right? So let's just keep 4 documents over here so that it looks similar to what we had. So in multi-dimensional space, they are just thrown out into four documents. Now, how do you search against Chroma database or an embedding database in a multi-dimensional space? How do you do that? So you take your own search text and you pass it through the same embedding function. Now this is crucial. If you ever create your original document, split it and create your collection with a particular embedding function, you have your search text go through the same embedding function. So whenever you are trying to do a similarity search, it will be able to look into the same multi-dimensional space for you. So every collection that you create, you have to create in such a way that the same embedding function is being used. And it is very simple. Just create your embedding function in one place and reuse it for the chunking process and for the retrieval process. For the retrieval process and for the chunking process, use the same embedding function. All right. So you will take your text, you will pass it through the embedding function, the same embedding function, and you will get the embeddings for that text out. And then you will do a similarity search in the Chroma database now. So whenever you do your embedding for the search text, you again get a bunch of text, bunch of numbers back. And what the Chroma database does in the search process so let's say this is your, and let me change the color of it. So let's say this is your embedding, your search texts embedding over here. And after you got this embedding, the Chroma database tries to put this embedding also somewhere in the actual database, right? So it tries to insert it. I mean, not really, but it tries to put it in the database. And then it finds the Cartesian distance between the search embedding and the previous embeddings that you already had, right? So it will try to insert it over here and then it will try to find, hey, which is the closest one, right? So this is one, and then the next one is probably this one. Then the third one is this one, and the fourth one is this one, right? So the smallest distance is this, maybe the next smallest distance is this, then the third smallest distance is this, and the fourth one is this. So if you had asked that, hey, send me the 2 closest documents to this document, so you will get this and this back, because this is what the closest distance is. So the database tries to find the closest Cartesian distance, right, for your search text, which is this one, for your search text versus all the other documents that are already here. So this is actually the retrieval process for it. So the whole process is broken down into two steps, right? One is the embedding process, where you take your original document and you insert it into Chroma database, into your embedding database. And the step two is you take your search text and then you search it against the documents that are stored into the Chroma database or into your embedding database. So at a very high level, again, the embedding process, right, the inserting into the database process is divided into two big steps. One is a chunking process. Chunking process means take your original PDF, convert into text, break into smaller chunks, and convert into a document. And then once you have your document ready, you pass that document to embedding function, create your embedding, put all your documents together, insert it into the Chroma database. And this is where your indexing part of the document is done. And now whenever you have to search, you take your search, pass it through the same embedding function. This is very important. And then you get your embeddings for the search text. And then you do a search in the Chroma database, similarity search, where you ask the database to send you back all the nearest or the closest distance document to your original document. So this is how end-to-end process works. And now when I will run the program again, it will make more sense. Okay, so what I'll do is I'll clear this out and I will run this program again. So this is Python RA pipeline.py. And what I have on the right hand side is this is my GPU monitoring that you see over here. And this is my CPU monitoring for this server that you see over here, right? So this is the GPU monitoring, this is the CPU monitoring, and I will keep an eye, I'll ask you to keep an eye on these tabs whenever relevant functions are executing in the background. So let's run this. So at the very first step, what I'm collecting is the search query, right? So I'm collecting this particular search text so that we have it ready for us whenever we need it, but we're not going to take any action on it yet because a search can only happen till we actually do the chunking and embedding process, right? So first we have to insert the original PDF and all that, and only then we can do search. But I'm just going to collect the search text at the start of the process. Just in case, and then I will let you know once we actually process this search text, right? So let me just collect this search text and let's do var is not good, right? Something I don't even know. I'm just putting some search text over here and let's see what happens. So now the whole process has started. So I have provided the original PDF over here. And this is where the original PDF is being picked up. And we are going to extract the text from the PDF using PyPDF2 library, right? So now we are going to convert it. So this is at the step number 1, and we are going to convert it into the text over here. So I'm going to hit enter, and it extracted 55 pages from that PDF document and it converted it into the text. Now in the next step, we will split this text into smaller manageable chunks. And like it says, it is essential because it allows us to process the document in segments, making it easier to handle the large text, and it is more effective while we are doing the generation of embeddings for us, right? So now we're going to split the text into smaller sections. And this is the very fast process. So CPU did not even feel anything. Boom, in just one go, it happened. Now, when we will have our smaller chunks available with us, we will generate documents from these chunks, right? So in order for us to generate documents from the chunks, all we have to do is to call one of the LangChain methods, and we pass in this particular text that we have and the file name, and we just generate a document. This is a very straightforward process. And these are individual smaller chunks and the documents that are generated now. So and in this, all we are showing is the first 200 characters right now for each chunk, but there are 108 chunks that are generated. And now, once we have all the chunks generated, and we have all the documents generated. Now the embedding process starts. For the embedding process, let's see what happens next. So for the embedding process or the indexing process, the very first step is embedding, right? So what we do is we now access the ChromaDB collection. So let's talk about that. So in ChromaDB, we can have multiple collections. In this case, we are using the test document collection uh, over here, right? So we just create an instance, a client connection, and we retrieve the test document collection as a handle so that we can insert into it later, right? So that's what we're doing. And then we hit enter, and now we will generate embedding for each chunk. So you see how we have each of these chunks created. So now we are going to generate the embeddings for each chunk, and we will insert it into the Chroma database. So as soon as an embedding is being created, it is being inserted too. So now you will see that the GPU is working over here. So this is where my embedding model is being hosted in this particular GPU. And you can see that this embeddings were being generated. And while the embeddings were generated, this particular GPU spiked, right? So now that the embeddings are done creating, the GPU spike has stopped, and we are at the next phase now. So we created embeddings and we inserted embeddings. So two things happened at the same time. We were creating it, inserting it, creating it, inserting it. So for each document, embedding was created, document was prepared, inserted. Embedding was created, document was created and inserted, right? So that is why you were seeing that this particular Olama server GPU spike was happening over here. And now we will retrieve the document based on the query that we entered. So when we will retrieve the document, again, you will see one small spike at the Olama server because it is again a call to the Olama server for the embedding function, right? So keep an eye over here again, and we will see a spike that happened over there. And now we generated the embedding for this, and you can see the embedding length is 1024. This is the dimension of that particular embedding, which means it is in 1024 dimension, right? We can only see in 3 dimensions. This system can see in 1024 dimensions. And now it is going to return back the results to us. So what we are saying is that, hey, for this document, war is not good. You have in your database 108 different documents stored, but I want 10 documents that are closest to this statement. Can you do that? So let's see what ChromaDB returns back to us. So this is what it gave back. And even though the document has about 1,000 characters, we are only returning the first 200 characters to print. I mean, in reality, the actual document is returned as a full 1,000 character. But over here, just so that the terminal looks pretty, I'm only returning first 200 characters over here. But for this thing, war is not good. This is what it returns, right? That huge forces were and whatnot in the heart of the enemy country. Like whatever it thought that the war not being good is the relevant text over here. It returned back to us, right? Maybe rejected and all that, some negatives of war not being good was returned over here too. Anyway, so this is what the whole end-to-end RAG, the first part of the RAG pipeline looks like, where you take your document and you put it into your Chroma database, and then you have your search text that you retrieve from the Chroma database. The relevant documents from the Chroma database. So what happens next in the RAG pipeline? So in the RAG pipeline, the next step would be you will get these bunch of text, most relevant text out. And then you will pass it to a large language model saying that, hey, this is the original text. This is what was retrieved from the PDF or whatever from your source. Can you answer the question which is the initial question is this: can you answer this initial question based on this context? And then the large language model answers this question based on the context that you have provided. I'll go over some of the relevant portions of the code over here, so things are easier to understand when you are navigating through this code base. So some of the things are at the very top. You will see the configuration section, and in this you can define your Olama API URL, which is localhost 11434 for you, and you can define the embedding model. And I'm using mxbai-embed-large. You can use nomic embed text also, that works pretty good. And then there is this chroma host section, right? So what is this? So if you go into this particular GitHub repo that I have, so github.com teachings rack tools, this is the repo, and I'll put the link in the description section also. You will see that I have mentioned some setup instructions over here, right? So one of the instructions are you clone this repo, go into this repo, create a conda environment, and then install the requirements, set up your Olama server, right? And the second part is that you have to set up your ChromaDB. I think this is not needed. .env is not needed, but I mean I'll fix this also if this doesn't look right. I think this is the chroma host 11 for local. This is actually correct, but you can get away without using env file because you also have the defaults over here. So if you want, you can put your env file over here, or it will just use the defaults from here. Anyway, so for setting up the ChromaDB, what I've done is I have pushed a Docker image for ChromaDB by going to the ChromaDB's GitHub repo, building it by myself, and then pushing it to my own Docker hub. So if you go to my Docker hub profile over here, there is a ChromaDB instance that you can pull and you can directly utilize, and it will really speed up your development process. So all you can do is Docker pull this particular image, and you can create a Docker volume over here so you don't lose the data every time when you spin up the container. And if you, like me, want to have the container started up at your server boot up all the time, which is what I like, so that you only have to run this once and forget it, there is a restart always flag over here. And this flag will make sure that anytime when you boot up your computer, your ChromaDB instance automatically gets spun up, right? So you don't have to run it over and over again. So this is just one time step that you have to do. And this will spin up your ChromaDB instance automatically. All it is doing is it is utilizing your 8085 external port, right? So this is the port that you will be using. The internal port is port 8000, but port 8000 is being used by so many different applications that I did not want to expose it directly. So I have exposed 8085 port, and this is your Chroma exposed port that you'll be using, right? And that is why the Chroma port is 8085 over here. And then there's some explanation that I have written over here, but you can check your ChromaDB once it is up, and then you will be golden over there. Now, once you clone the repo, you will also need to create a docs folder and put any PDF file in there, right? So if you go back over here, this is what the directory structure part is talking about. They just create a docs folder and put any sample PDF over there. In my case, I have the sample PDF called worldwar2.pdf. And then let's go back over here. Once you have put your PDF over there, you can run the script. So I keep on changing the script names. That's why there is a generic name over there. In your case, you can navigate to langchain folder, ra_pipeline.py, and this is what is executing. So if you go down at the bottom, right? So when you execute this, this is the section that gets executed, right? So in this section, you can specify which file name that you have. So in my case, I have one folder up, docs folder, worldwar2.pdf. So one folder up. So we are in the langchain folder, right? One folder up is the docs folder. And this is the file name that we have. And this is any collection name that you can provide. I just provided the test documents collection over here, just a sample collection name. And then this is where your execution starts. So you remember when we started running the program, it had stopped. Initially, it was waiting for your input for the search term that you want to search for. This is where that very first step is. And then the second step is chunking of the documents. So once you enter your original text, this takes the file path that you have entered over here, which is this particular file path. And then we go to the intelligent chunking process. In this, we already have the file now, and we start the intelligent chunking. And this is, if you see extract text from PDF method, if we click over here, we go to our extract text from PDF, and over here we are using the PyPDF tools. Now attributes over here, if you see PDF reader, this is coming from PyPDF2, which is on the top over here, PyPDF2. We are reading this file path, and then we are extracting the text and making it like a one huge big text over here. And then once we get all the text from this PDF, we just split the text into smaller sections. And what we have used for splitting over here is recursive character text splitter. So if you remember, I was talking about how there are a ton of different ways in which you can divide the, or you can split the text. You can divide it into smaller manageable chunks. There are multiple ways. One of the ways is recursive character text splitter, which is where you can define the chunk size that, hey, I want 1,000 character chunk, and I want a 50 character overlap, and I want this kind of separator between two chunks, right? So this is how I would split it. So we get all the different chunks over here, and then we print it out, and that's it. And then what we are going to do is create documents from our chunks, right? So let's go back over here. Let's take a look. So we will create, we have split it, and now we're going to create these documents out of the chunk. And this is what we are looking at over here. So to create the documents from the chunk, it is simple as utilizing this particular document object from LangChain, and then providing the chunk and providing the metadata, right? So there are two attributes to it, the chunk and the metadata. We are providing these two over here. And then we are just printing it out. You see, if you remember, I told you that I'm only printing the first 200 characters. And this is what I meant by that, that even though we are storing the whole document, the whole 1024 characters, we are only printing 200 characters over here. So that looks pretty. All right. So once we have done the chunks and we have returned all the documents back, let's go back down and see what happens next. So let me go down over here. So now once we have done the chunking part and we have all the documents, what we have to do is index these documents into the Chroma database. Let's see what happens in the indexing process. So in the indexing process, we go in, we get the client connection. So this is now doing the connection from our Chroma database instance. We are getting a connection over here. We are building a Chroma client, and we are having the collection name that is being passed to this method, right? So we had that test collection name over here, and then now we have this collection. So we're using the Chroma client to get a collection, and we are passing the collection name, and we have a collection. And then once we have the collection, we can do collection.add method to add the documents into this collection, right? So this is where we already are passing the documents that we have created. We are creating our collection over here, and then we are iterating over the documents, right? So we are iterating over documents one by one. We are creating IDs. So IDs are as simple as chunk underscore the I, the loop number over here. We are passing the embeddings from the document. We are generating the embedding over here too. So this is this step. If you see, so we are generating the embedding, and we are collecting the whole document over here, right? So this is the generate embedding function, and this is the collection of the document. And I'll show you those two steps. So this is the generating embedding, and this is the collection, we are putting those document attributes together and putting in collections.add, which is inserting it into the Chroma database. And once we are done with these two steps, we are actually done. We are done with the indexing process, right? So once we are done with the indexing process, putting all the data in our database, Chroma database, then we can go down and go to the next step, which will be the retrieval process. So let's go down and see. So once we are done with the indexing, now we are going to retrieve. So in the retrieval process, we take our query that we collected originally as part of the input when the process was starting, we pass that into the retrieval process, right? So we are over here now. So now we are taking this input text and passing it to the embedding function. And let's take a look at that now. So we go to the retrieve text method. Let's see what's happening there. So in this retrieve text method, we are again getting the collection, Chroma client, and the collection, right? So we're making a connection over here and we are using the same collection name, right? And we are then getting this collection. Now we are using the same generate embedding method. So if you see, this generate embedding method is being used twice. Once it was being used when we were inserting the documents, right? So when we were inserting the documents, we used this generate embedding method. And then now when we are retrieving, we are using the same generate embedding method, right? Which is what I was talking about. So this same generate embedding method was used when we were inserting it into the database. And the same generate embedding method is being used when we are performing the search, right? So the same method is being used, which is very crucial and critical because we want to use the same embedding numbers to perform the similarity search. And before we proceed, let's take a look at this embedding method. What does it do? So in this, if you see, all we are doing is we are going to the Ollama server /API/embeddings, and we are just passing the embedding model name in here and getting the response back as the embedding. That's it. It's as simple as that. So let's go back to our search, which we can go over here by taking a look at retrieve text. We got the collection name, we got the embedding, and now you can do collection.query. So you see, when we had the insertion of the documents, we were doing collection.add when we were inserting the documents, but now we are querying the documents. So for querying, we will do collection.query and we will pass the query embeddings over here. And then we will say that, hey, give us the top 10 results back. So we get the top 10 results back out of it by passing the query for the query embedding, right? So now we get the top 10 results back and we are converting these top 10 results back into a more readable format. So we are done with the similarity search over here, and this section is just to get the results back, make it in a more readable format, and then send it to the final results section so they can be printed out. So now once you have your final results over here back in a more readable format, you can now print it out over here. And this is it, end to end. This is what the retrieval part of the RAG process is. So after watching this video, you should now know what the indexing process is, how you take an original document and index it into a Chroma database. And then you should also know and understand what the retrieval process is, that how you take your text and retrieve the most relevant chunks of data out of your indexed documents. And then you only get the top few searches back based on the similarity search. That is nothing but the Cartesian distance between two objects that are positioned in a multi-dimensional space. All right, as usual, the code and the link will be in the description section. And thank you guys for watching. In the next video, I'll build a end-to-end RAG pipeline.